Let us learn about touching circles. Let us draw two circles in various ways. Given two circles are given in a plane are said to be touching circles or tangent circles if they have one and only one point of contact. If two circles touch each other and one circle is in the interior of the other circle, then the circles are said to be touching internally. Here, circles with center P and Q touch each other internally at point A. If two circles touch each other such that one circle is to the exterior of other, then the two circles are said to touch each other externally. Here, circles with center P and Q touch each other externally at point A. Let us look at the theorem. If two circles are touching circles, then the common point lies on the line joining their centers. Given touching circles with center P and Q, point A, which is the common point of the two circles. To prove, the point A lies on the line PQ. Proof. Assume that the point A does not lie on the line PQ. Draw the line AR perpendicular to the line PQ. Take a point B on the line AR such that R is in between A and B and segment AR is congruent to segment BR. Now, in triangle PRA and triangle PRB, segment PR is the common side congruent to itself. Angle PRA is equal to angle PRB since each is 90 degrees. Segment AR is equal to segment BR by construction. Therefore, triangle PRA is congruent to triangle PRB by side angle side test. Segment PA is congruent to segment PB by congruent sides of congruent triangles. Therefore, PA is equal to PB. But PA is the radius of the circle with center P. Therefore, the point B lies on the circle with center P. Similarly, we can prove that triangle QRA is congruent to triangle QRB. Therefore, QA is equal to QB. But QA is the radius of the circle with center Q. Therefore, point B lies on the circle with center Q. Thus, the point A and B are common to both the circles. This contradicts to the definition of touching circle. Hence, our assumption is wrong. Therefore, the point A lies on the line PQ. Hence, if two circles are touching circles, then the common point lies on the line joining their centers. Let A be the common point of the touching circles with centers P and Q. Let L be the line tangent to the circle with center P at the common point A. Is the same line L also the tangent of the circle with center Q at the common point A? Take any point B on the line L, then angle PAB is equal to 90 degrees. Also, by the above theorem, the points P, A, Q are collinear, and hence angle PAB is equal to 90 degrees. We get that the line AB, which is same as the line L. We conclude that if two circles touch each other, then there is a line through their point of contact and a tangent to both the circles called common tangent to the touching circles at the point of contact. Also, if two circles are touching internally, then both the circles are on the same side of the common tangent. Here, line L is tangent to the circle with center Q and circle with center P, and both the circles touching each other internally. If two circles are touching externally, still there is a common tangent to both the circles. Here, line L is tangent to the circle with center Q and circle with center P, and both the circles touching each other externally. Let us look at the examples. Example 1. Figure shows that one circle touching another internally. Radius of the larger circle is 16, while that of the smaller one is 6. Radius AB of the larger circle touches the smaller circle in P. Find AP. Solution. If T is the point of contact of the circles and C is the center of the smaller circle, then points A, C and T are collinear. Therefore, AC plus CT is equal to AT. Therefore, AC plus 6 is equal to 16. Therefore, AC is equal to 16. Segment AC being the hypotenuse of the right-angled triangle APC, we have AC square is equal to AP square plus PC square. Therefore, 10 square is equal to AP square plus 6 square is equal to 10 square minus 6 square is equal to 64. Therefore, AP is equal to 8. Example 2. The radii of two circles are 25 cm and 9 cm. The distance between their centers is 34 cm. Find the length of direct common tangent of these circles. Solution. As 25 plus 9 is equal to 34, so the circles touch externally. Let O and O' be the centers of the circles having radii 25 and 9 respectively. Let the direct common tangent to them touch at P and Q respectively. We want to find PQ. Draw O' parallel to PQ. Therefore, RP is equal to O''Q is equal to 9. OR is equal to OP minus RP is equal to 25 minus 9 is equal to 16. Now, from right-angled triangle ORO', OO' square is equal to OR square plus RO' square. 34 square is equal to 16 square plus RO' square. Therefore, RO' square is equal to 34 square minus 16 square is equal to 34 plus 16 into 34 minus 16 is equal to 50 into 18 is equal to 900. Therefore, RO' is equal to square root of 900 is equal to 30. Therefore, PQ is equal to 30 as PQO'(R) is a rectangle. Let us solve exercise 2.2. Number 1. If two circles touch externally, then show that the distance between their centers is equal to the sum of their radii. Given circles with centers A and B touch each other externally in the point T. Segment AT and segment BT are their radii respectively. To prove AB is equal to AT plus TB. Solution. From the figure, we can see that the circle with center A and center B touches each other externally at point of contact T. Thus, point A, T and B are collinear. Therefore, by the property of betweenness, AB is equal to AT plus TB. That is, AB is equal to AT plus BT. Number 2. Two circles with centers A and B are touching externally and a circle with center C touches both externally. Suppose AB is equal to 3 centimeters, BC is equal to 3 centimeters and CA is equal to 4 centimeters. Find radii of circles. Solution. Circles with centers A, B and C touch each other externally in the point P, Q and R respectively. Let the radii of circles A, B and C be R1, R2, R3 respectively. by the property of centers and the point of contact of touching circles externally, AB is equal to AP plus PB, since P is in between A and B, is equal to R1 plus R2. But AB is 3 centimeters. Therefore, R1 plus R2 is 3 centimeters. Mark it as 1. Similarly, BC is equal to BQ plus QC, which is equal to R2 plus R3, is equal to 3 centimeters. Mark it as 2. AC is equal to AR plus RC is equal to R1 plus R3 is equal to 4 centimeters. Mark it as 3. Adding 1, 2 and 3, we get R1 plus R2 plus R2 plus R3 plus R1 plus R3 is equal to 3 plus 3 plus 4. That is 2 multiplied by R1 plus R2 plus R3 bracket closed is equal to 10. Therefore, R1 plus R2 plus R3 is equal to 5. Mark it as 4. Subtracting equation 2 from equation 4, we get into brackets R1 plus R2 plus R3 minus into brackets R2 plus R3 is equal to 5 minus 3. R1 plus R2 plus R3 minus R1 minus R2 is equal to 2. On cancelling the opposite terms, we get R1 is equal to 2 centimeters. Substituting equation 3 from equation 4 into brackets R1 plus R2 plus R3 minus into brackets R1 plus R3 is equal to 5 minus 4. R1 plus R2 plus R3 minus R1 minus R3 is equal to 1. On cancelling the opposite terms, we get R2 is equal to 1 centimeter. Substituting R2 is equal to 1 in equation 2, we get R2 plus R3 is equal to 3. 1 plus R3 is equal to 3. R3 is equal to 3 minus 1 is equal to 2. Therefore, radius of circle with center A is 2 centimeter, with center B is 1 centimeter, and with center C is 2 centimeter. Number 3. 3 congruent circles with centers A, B and C and radius 5 centimeter each touch each other in points D, E and F as shown in figure. Number 1. What is the perimeter of triangle ABC? Number 2. What is the length of side DE of triangle DEF? Solution. Circles with centers A and B touch each other externally in the point D. Therefore, AB is equal to AD plus DB, since points A, D and B are collinear, is equal to 5 plus 5, as radius of each circle is 5 centimeter, is equal to 10 centimeter. Circles with centers A and C touch each other externally in the point F. Therefore, AC is equal to AF plus FC, since points A, F and C are collinear, is equal to 5 plus 5, as radius of each circle is 5 centimeters, is equal to 10 centimeters. Circles with centers B and C touch each other externally in the point E. Therefore, BC is equal to BE plus EC, since points B, E and C are collinear, is equal to 5 plus 5, as radius of each circle is 5 centimeters, is equal to 10 centimeters. Therefore, number 1, perimeter of triangle ABC is equal to AB plus BC plus AC is equal to 10 plus 10 plus 10 is equal to 30 centimeters. Number 2, in triangle ABC, point D and E are midpoints of side BA and side BC respectively. Therefore, by the theorem of midpoints of two sides of a triangle, DE is equal to half of AC is equal to half of 10 is equal to 5 centimeters. Thus, number 1, perimeter of triangle ABC is equal to 30 centimeters. Number 2, length of side DE of triangle DEF is equal to 5 centimeters. Number 4. In the figure, A and B are centers of two circles touching each other at point M. Line AC and line BD are tangents. If AD is equal to 9 cm and BC is equal to 6 cm, then find lengths of segment AC and segment BD. Solution. AM and AD are radii of same circle. Therefore, AM is equal to AD is equal to 9 cm. Mark this as 1. Similarly, BM is equal to BC is equal to 6 cm. Mark this as 2. AM plus MB is equal to AB as A, M, B are collinear points. Therefore, 9 plus 6 is equal to AB from 1 and 2. Therefore, AB is equal to 15 centimeters. Mark this as 3. By tangent perpendicularity theorem, radius AD is perpendicular to tangent BD at point D. Triangle ADB is right-angled triangle. Therefore, by Pythagoras theorem, AB square is equal to AD square plus BD square. Therefore, BD square is equal to AB square minus AD square. BD square is equal to 15 square minus 9 square from 1 and 3. Therefore, BD square is equal to 225 minus 81 is equal to 144. Taking square root, we get BD is equal to 12 centimeter. Similarly, in right-angled triangle ABC, by Pythagoras theorem, AB square is equal to BC square plus AC square. Therefore, AC square is equal to AB square minus BC square. Therefore, AC square is equal to 15 square minus 6 square from equation 3 and 2. Therefore, AC square is equal to 225 minus 36 is equal to 189. Therefore, AC is equal to square root of 189 is equal to 3 root 21 centimeters. Therefore, length of segment AC is equal to 3 root 21 centimeters. Length of segment BD is equal to 12 centimeters.